Hello, my students and relative kittens. All right, we're going to talk about, on this episode of MathMeowTics, we're going to talk about rational exponents and radicals. In this latest and greatest next episode, we are going to talk about this funky little sign and images right here underneath this key concept. I have this picture right here. This is really all you need to pay attention to. I have this little symbol here. It looks like a little check mark with a combination of a division symbol. All right. Then I have, that is called the radical sign. Okay. And then underneath that radical sign, we have a value. It could be any value. It could be a variable. It could be a number. It could be anything. All right. And we call that value underneath the radical sign, we call that the radicand. Now, if you look at this little picture here, I have a value that's in the little crook of this radical sign. Okay. That n value, that n term, the nth root, that is called the index of our radical. All right. So the index gives the degree of the root. All right. That means how many times whatever the nth root of that. So it could be the cube root, it could be the square root, it could be the fourth root, it could be whatever nth root of that number, a, that's the number underneath the radical sign, if b to that nth root is equal to the a value. So, for example, let's say I have 3 to the 4th power. Okay, that 3, our b is equal to 3. That's the base of our exponent. All right. Now, we have the fourth, we have 4 here. So if we think about this, that is going to be 3 times 3 times 3 times 3. 3 times 3 gives us 9. So that's going to end up giving us 9 times 9, which will give us 81. So whatever, this is going to give us the value of A. Now, we could also look at it in terms of this as well, but we'll get into a little bit deeper later on. Now, if there is no index, all right, if I don't say, let's say, let me erase this. Let's say I have the square root of 4, okay? If there's no index number right here, it's blank. We don't consider that 1, we consider that degree to be 2, which means, we've heard this before, square root. And that b, that number b, is the square root of a number, square root meaning that number times itself twice. Okay, so our b value, in the case, if I have 4, our a value, this is our a value. If our a value is 4, that means that there's some number multiplied by itself twice, which will give us 4. Well, that's 2 to the 2nd power. 2 times 2 will give us 4. Okay, 4 being our a value underneath. So our b would be 2 in this case. Now, the square root of a value is the non-negative square root. We also call that the principal square root. So the square root of 4, that's in this case of me writing that is our principal square root. And let's say, for the sake of argument, that that was negative square root of 4, that would be the negative square root. Now, in the purpose of this lesson in Algebra 1, if I have the negative a, or the negative, let's say the square root of negative 4, it's not really a value that's in the real number system, so that we can't solve that. It's not a number under the real number system. Now, that number specifically comes into play with the imaginary or the complex number system, and you will get that into that much later. Or if you're particularly curious, you can Google imaginary numbers, and that might or complex number, and you might go down the rabbit hole. Now, going on. We're going to talk about the nth root of a is a real number, and m and n are positive integers. So that's this section right down here. And if we look at this, we have a to the 1 over n is equal to the nth root of a. Now look, that denominator, that number in the bottom of our fractional exponent, that is our index. Okay? Now, if, for example, in the case of the second example, I have a to the m over n, I would rewrite that to the nth root of a to the m power. That number that's in the numerator of our fractional exponent, that's going to be the power, the exponent power underneath the radical sign. Or we could also take it out and be a multiplier, okay, as we do in the further example here. Now, let's say, for example, I have, let's say, 16 to the power of, let's say 4, no, let's say 3, yeah, let's say 4 halves, okay? Now, I can also rewrite this as 16 to the power of 1/2 times 4. I know that 4 times 1/2, the rules of power of exponents will tell us that we multiply when we have a power, exponential power to a power, that we're going to multiply those. So, I know that I can rewrite this 4 halves to being 16 to 1/2 to the power of 4. I know that 16 to the power of 1/2, there's some number that I would multiply by itself twice that would give me 16. That number is 4. So 16 to 1/2 would equal 4, so I would write that as 4 to 4. If, in fact, I were actually solving that. But right now I'm not. I'm just going to write this as a number with a radical sign. So let me not get too distracted there. All right, so I'm going to rewrite this. This nth, that number in the denominator, that is my radical, that would be my index number. So in this case, since it's 2, that means I'm not going to put a symbol there. And now, this 4, the number in the numerator, that's going to be my power. So I'm going to say 16 to the power of 4. Or, we can write this to the square root of 16, and then in parentheses, to the power of 4. Okay? Now, think about it this way. If I were to rewrite that number there, if I were to rewrite this, this would be 16 to 1/2. And then again, I'm going to keep that 4. So as you can see, these are all equivalent statements and ways to write our expression depending on what we're asking for. And we want to be able to break it apart and look at it in these different ways so that we can do things like multiply and combine, or even simplify further without the use of calculator. Because many of these exponential expressions, we won't even need a calculator, and we can actually, our human brains will allow us to calculate it faster. All right, now that will be the end of this episode of MathMeowTics and rational exponents and radicals. Hope to see you on the next video. See you then.